Hello, everyone, and welcome to our Data Park Insights webinar on enhancing ESG, environmental and energy efficiency through innovative data applications. All right, so now just some quick introductions. My name is Molly Colwell, and I'm an applications engineer with Data Park. I've implemented Data Park and helped customers set up their environmental and energy systems for quite a few years. And yeah, I'll go ahead and let Pekka introduce himself.
Thank you, Molly. My name is Pekka Vänni. I'm Regional Director and Sales Manager for Data Park on EMEA region.
Great, thanks. Let's go over the agenda. We're gonna start by going through the environmental and ESG management options, and then some environmental and sustainability items in data collection, regulatory monitoring, reporting, sustainable operations, and then the impact of the sustainable process and real-time monitoring. And then we have a use case to review, which I'll jump back in and review the use case, and then we will have time for Q&A. So without any further ado, I'll hand it off.
Thank you, Molly. Thank you very much. Industrial plants have obligations for regulatory control of their environmental emissions, as we know. Such permits are plant-specific and granted by local environmental authorities. The plant operator has an obligation to monitor emissions, typically gas emissions to air and effluent emissions to water systems. If the agreed targets are not achieved, the operator is penalized, and in the worst case, the plant is shut down until corrective actions have taken place. However, in today's business world, it's not enough that companies are fulfilling their requirements set by authorities. The companies have also their social responsibility regarding quality of the air, pureness of the water, and even taking their share in the fight against climate change by minimizing their carbon footprint. But in companies where sustainability and social responsibility are high on their agenda, environmental applications can go well beyond mandatory requirements. In the end, it all starts from process management. Stable process is operating more effectively also from environmental perspective. Familiar smell of the pulp mill becomes stronger around shutdowns. Peak loads to effluent treatment plants have adverse impact in microbes' capability to do their job. The hardest for socially responsible companies is to face a situation when, as a result of equipment failure or human error, heavy pollutants hit the downstream ecosystem in waters. In such situations, no penalty or formal apology will compensate the damage to company's brand image. In this webinar, we will elaborate how advanced information applications can be applied to help your company and plant to take care of your social responsibility and regulatory monitoring of environmental emissions. Gas emissions are typically measurable. You have analyzers and transmitters in your smokestack that provides a continuous measurement of your gas emissions. Then you can keep track on your NOx, TRS, whatever is defined in your environmental permit. For water emissions, the situation is more complex because online measurements are not possible for all key performance indicators. One typical component in an environmental permit is Biochemical Oxygen Demand, BOD. Let's use that as an example. BOD is a key indicator of water quality. It's measured in the laboratory from a collection sample of purified water. The sample is held for several days, like 5 or 7, at certain temperature until the tests can be done. The sample represents certain time period. The collection cycle can be, for example, 1 day or perhaps a weekend. Then you have to combine the test result to wastewater quantity of the collection period and calculate the actual biological oxygen demand. Doesn't sound straightforward, or what do you think? First of all, your lab data management application must be able to handle concept of collection samples, provide the right timestamp so that you can combine test results with the quantity of wastewater over a collection period. The calculation can be triggered only when the test result is available. Then your calculation engine must be able to apply the formulas with the data which is few days old and save the data with timestamps in the past. In addition, the authorities may require audit trail to secure that the data is not manipulated. If such functionalities are not native for the system applied, the application may become complex, hard to maintain, and costly. If you are implementing ISO 50001 compliant energy management system, you need to collect data related to thermal energy consumption, like pressure, temperature, and quantity of steam, and then calculate energy content. For measuring electricity, data is collected from electric meters, and in some countries, authorities require capability to absorb significant energy units in great detail. As said, when applied software product has native features to support environmental applications, implementation is fast, cost-effective, and easy to maintain. The basic function is historian, which is used for continuous data recording. It captures and stores automatically real-time environmental and energy data. It also provides high data integrity and ensures accurate and reliable data collection from various sources, including sensors and analyzers. And finally, it provides a long-term data storage. It maintains historical data for trend analysis, compliance reporting, and performance benchmarking forever if so desired. Manual data entries are needed, first of all, for lab data management in environmental applications, but also for solid waste. For solid waste, the application is typically fairly simple. The waste that used to go to junkyards are nowadays raw materials in the circular economy. You can register batches via manual data entries. I already described complexity related to KPI calculations in environmental applications. In energy performance calculations, they can be much more complex. Naturally, you have to be able to calculate thermal energy content from steam, pressure, temperature, and quantities, perhaps tons of oil equivalents or carbon monoxide emissions. But in some countries, authorities are defining their ENPI, energy performance indicator, calculations in detail. And then the system needs to be adapted to local requirements, just as HUMAC kilowatt hours KPIs in France. In the information applications, you typically visualize the data with trends and control limits as system generates alarms to secure situational awareness. Trending is applied for real-time monitoring as well as analysis of historical data. KPIs are made visible for everyone. Performance is transparent and continuous comparison of configured limits emphasized with smart alarming systems are the core elements of today's management system. Interactive graphics provide at a glance view to wide variety of data, combining measurements, lab values, soft sensors, and calculated KPIs to single display. It's also a sound foundation to quick troubleshooting. Drill down to trends makes it possible to quickly move to analytical functionalities. In many industrial operations, deteriorating performance develops slowly and changes are difficult to observe. Trends are good tools in visualization, but modeling applications can provide advanced support. Combining all that with smart alarms, intelligent alarming functionality that generates alerts and distributes them effectively can bring situational awareness to completely different level. ISO 50001 compliance is an indication of plant's commitment to continuous improvement in energy efficiency. Although similar to ISO 9001 for quality and ISO 14001 for environment, ISO 50001 emphasizes utilization of data-driven systems. Governments are supporting industrial operators with subsidies to implement data-driven energy management systems. Subsidies can be significant. In some countries, 30% of the investment, in some countries more than 100% of the investment value. Such a system needs to be able to fulfill the standard, for example, with functionalities like data collection and storing, calculation of energy performance indicators, data normalization and harmonization, visualization and analytics, alarms and reporting, and management of plan, do, check, act cycle. Better energy efficiency leads also to better operating costs. Last year's high energy cost has been a regular discussion topic. No matter what happens with level of energy costs in the future, high volatility of energy prices shall remain. While we desire to use more green energy, i.e. wind and solar power, we are more dependent on weather conditions. Thus, advanced companies are going beyond the requirements of standard and building applications to predict energy costs and optimize energy utilization based on forecasts. Sometimes selling electricity may become more profitable than main product of the plant. For such an application, you need a system designed for data integration. You need to be able to build data interfaces to energy trading platforms and weather forecasting systems, harmonize the data to a useful format, and combine with other data for production optimization. Once the data is continuously recorded, you can make the reports for own operational use, perhaps also send the requested data to local authority who keeps their own records. Very often you need to have audit trails and other means of data security to provide evidence that data is not manipulated. Finally, you need a reporting application that can be used for publishing the results in desired format and distribute to all relevant stakeholders. The data for reporting needs to be saved and available for years, practically forever. And some authorities may request the reports in certain format to integrate data into their own applications. That's why reporting tools need to support flexibility to adapt the format to local requirements. In Data Park, you have two main toolkits to create and distribute reports. Park Report provides flexible means for those familiar with SQL queries. You can create tailor-made content, format, and generate and distribute reports automatically. Data Park's Excel add-in is another option. You can easily import all relevant data, manual entries, online measurements, calculated values, incidents, whatever, and then create the report layout with familiar Excel functionalities. For companies having sustainability and social responsibility high on their agenda, the regulatory compliance is just the beginning. Who wouldn't be proud of being the employer that fights against climate change and give employees work a higher meaning? Sustainable operation is also an indication of high operational efficiency. Less emissions means better production efficiency and more effective utilization of raw materials. Lower carbon footprint is indication of high energy efficiency. Decarbonization often means also more highly volatile wind and solar power. How the plant can take care of their share of sustainability, fight against global warming, and save our planet for next generations. As an example, CO2 footprint of the plant is a difference of CO2 of incoming material and energy flows and of outgoing materials and energy. On the plant, you are losing CO2 mainly in emissions to air. Energy efficiency is in a key role in minimizing CO2 footprint. Fighting against climate change is a global initiative. A plant can do its share. Saving local ecological system is an effort that is on plant's own full responsibility. It's quite common that when you start the plant, increased level of odorous gases get attention from publicity. Concerned people are calling authorities if everything is under control. More unstable the process, more costs. But every now and then we hear of ecological catastrophes. Downstream water system has been polluted, dead fish are found in volumes, and heads are turning towards the industrial plant on the upstream. Typically, such a situation is a result of equipment failure or human error. Tank of acid chemicals broke, or subcontractor left a manual valve open in the maintenance shutdown. Spill, bypassed, or passed through an effluent treatment plant and ended up to the river. In addition to damages in the ecosystem, the effluent treatment plant may be paralyzed for weeks. Is there anything we can do to prevent such situation? Yes, of course. There are many applications that are helping you to observe such abnormal situations and anomalies. You can build alarms on tank levels, you can build alarms on pH levels, you can build many types of alarms, but the challenge is that these alarms very often must take into account multiple inputs and conditions like operating point or production speed. You need an advanced alarming system that can take into account the nature of operations, nature of the process, and build a logic that makes the alarms meaningful. Also, to have early warning, you may want to build soft sensors to have an indication of increasing load, like on the effluent treatment plant. And as discussed earlier, key performance indicators cannot be measured online, but you can perhaps use COD, online measurement, to estimate biological oxygen demand, but you can also use statistical models to observe obvious changes in process conditions. Next, Molly will present you the use case as an example of our capabilities.
Great, thank you. Yep, so now we'll dive into a use case. So we had a project that was going to be a user-friendly environmental and energy management system. And this project was going to be from data entry to reporting. So we needed to take what they had and do some replication and then create some new tools that they didn't have and some more functionality behind it. So they wanted to have multiple data entry screens that were similar to the current system, so there wouldn't be a lot of learning into how to use this new system. They also wanted to incorporate visualization and with notifications. So this would be alarms and trending and graphics as well, to make sure that everyone who needed to know the information and needed to see what the values were, they could see them quickly and on one screen. And then finally, they needed some regulatory reporting, and that was in a couple of different formats. So we'll kind of look at that. And the steps went like that as well. So we started off creating some MDEs and some graphical MDEs so that we could replicate the old system. And then we moved on to adding limits to either the process tags or the MDE tags. And then with those limits, we added alarms where they were needed so that they could send out notifications. And then we were able to create graphics and trends for people to access the MDE screens for quick navigation, and then also to view the data in one spot. And lastly, we had a few reports that were made in standard formats for regulatory agencies. So let's kind of step through those one by one. So first, we have a graphical MDE, and this was for wastewater entry. So the lab had some tests that they needed to do on a regular basis to make sure everything was okay to dump the water into a river. And so in order to do that, there were lots of checks that needed to happen. And so we have on the left side here, the manual data entry screen that looks very similar to their old system. And then we're actually able to put the specs right above the entry value. And then on the right-hand side here, we have some process trends so that we're testing pH, but we also want to see what the process real-time pH is, and same with temperature and some other key factors. So we're able to see some real-time data right at the same time as we're entering data. And then here in the bottom section, there's some tests that have a delay in order to get those results. So we have the 24-hour BOD and the 5-day BOD with different specs as well. And this MDE is nice because we can actually do a query-based MDE. So instead of actually adding a new record every time we have a 24-hour or 5-day test, because it's a whole day later, we can actually have this query-based where we're getting all of the records from the entry above, and we can select which day and which hour our 24-hour test is for. And then that's where we can enter the record. So this was a really nice way to kind of keep all that information together and not kind of wonder, is my 24-hour test that's labeled the 25th, is it for the 25th or the 24th? This way, there's no confusion because it's using the same date, the same timestamp as the records above. And then we also had a few standard MDEs that we used, and so just wanted to show this simple screen that's more Excel feeling. You just have a grid, and we have some calculations in here as well as groups. So the groups just help separate the information. Maybe you get propane fuel in the morning and then diesel in the afternoon or something. You don't have to, it's easy to see where all the information goes. And these are collapsible, so sometimes if you only have to do a certain entry once a week or something, then you could collapse that so you don't see it all the time. Yeah, just another example of the standard MDE. And as we pointed out earlier, you can put calculations in here, which there's a calculation in this one, and there were some calculations in the previous one as well. The next step was to take all that data that we had and apply limits to it. So we wanted to apply limits first so that you could actually see those values on the trend. If we just skip straight to alarm and we say, hey, we want an alarm when this tag is above 10, we're not actually going to see that 10 line like we do here on the trend. So that's why it's important to start with your limit, especially if you want to see it on the trend, and then create an alarm off of it. So we were able to create limits with both our MDE and our process tags. And if you have limits maybe from another system, we're actually able, you can bring those in. So you can edit your limits on your original system, but still view them in DataPark so that you're not editing limits in two places. So once you have your limits made, you can then go to the alarm configuration window and use this open limit-based alarms button. And then that will open all of the limits that all of the tags with limits. So it shows the spec and control limits, so you could choose what you want to have an alarm on. In this case, we were just alarming for spec limits, and I can easily check all of these off, and the status of the plus indicates that I want to create a limit for this, an alarm for this. So now I just created 10 alarms very quickly, and I didn't have to go in and manually add all of those because I did the work on the front end with the limits. Another reason you might want to set up alarms is that it enables you to send notifications or workflows. So a notification would be like an email. When something goes out of spec, you want to make sure the supervisor knows or someone else. And then a workflow, you can actually use our Park Task workflow now with alarms and maybe schedule a report to send out or collect some more data so that if you have that excursion, there's some more information you can know about it, or you have a park report that's sending out some information to help capture that excursion. And when it comes to tracking these excursions and setting up the alarms, you can also then create a reason tree specific for environmental reasons or energy reasons that you may want to track. And we've seen people do this with MDE or with the reason tree. So with the reason tree, it would just act like a downtime alarm, and you would be able to edit the reason and write a comment. With an MDE, we can actually use that query-based MDE for getting all of the alarms, and then add that to your MDE. So if you need more information for an excursion besides just a reason and a comment, an MDE might be the way to go, because then you could enter in more data points, which you might need to use for reporting later. So it just depends what's going to work best for your site. But if you do go the route of alarms, you're then able to use a Pareto chart to either directly from a trend, or you can create a new one. And the Pareto really lets you see what are your highest number of excursions or the most amount of time. And then with evidence, that's a tag amount. You can put a tag in there to actually calculate maybe the sum of something during the excursion or the alarm. So our evidence could be how much were we over. And then with the reasons, you can actually have reported reasons and non-reported reasons. So, excuse me, if maybe durations are short and our excursions are short or something and they don't need to be reported, or if they're within a certain barrier, maybe you have control for non-reported and then your spec is your reported reasons, then you're able to actually see the non-reported reasons, what those are, and how to minimize them so they don't become reported reasons later. So that's another use case and how you can use alarms. So now that that was all set up, they really wanted a navigational screen to be able to jump from one place to another instead of using just the file explorer. So we color coded it a little bit so that green was going to be data entry, blue is going to be a graphic, the orange is a park report, and then the black is going to be a trend. So we kind of color coded this a little bit, and then they're able to click on something, say the environmental summary, which will then bring you to a summary page. And the nice thing about these graphics is that when you go to a page, it actually flashes the button of the previous page you were on. So in this case, if we jumped over to this screen, the home page button in the upper right would flash so that you knew how to get back to where you were. You can always use those back buttons here at the top to navigate back and forth between screens, but that's just another way you can do it. So we created a couple dashboards to see all of the information in one place. This one is a combination of energy, water usage, and water discharge. And we have some lab data, as well as if the water is actually going to be retreated or going back to the river. So we're able to kind of see all of the information they need to see in one spot, and then you can use these buttons to navigate to a center line or the report or some more lab data and do that. And then we just have another quick example of a dashboard, kind of blocked out all the information here, but it just kind of shows that, you know, you can have these grids and have the specs maybe underneath about the limits that you want to stay within, and then the daily average if you're getting multiple values versus the current average, the current value. So that was just one example, and these can also change colors if your daily value is beyond your limit. So really just wanting to see all of the data in a single view. And then off to regulatory reporting. So for this, we had an Excel sheet, and we were actually able, we've done this quite a lot, where we use both the data normalize button and the data norm calc button to create a report. So basically, this is the data normalize sheet, and in this case, we're pulling in alarm events in order to calculate the the excursions for the quarter. And we can see my date and time are actually pointed to the facility info tab. And that's where I have the start and end time, so that when I'm pulling this data for all of these different reports, because there's quite a few of these reports, all those green ones, it will actually update all of them at once. So we don't have to go in and update the date in multiple locations, because that would be pretty tedious. So once we have this set up, we actually run the report on one of these report pages with the data norm calculate sheet. And so again, we can see our start and end time is there. It's going to be coded back to that facility information tab. And if the sheet option lets you just run one sheet if you want, but if it's blank, it will run all of your data normalized sheets. So when we hit calculate, what it's going to do is it runs that data normalized sheet, and then we have equations in here to sum up all of the information and those durations of downtime or excursions throughout this sheet. Yeah, with a click of a button, we have all of the equations already set up. So there's very little manual editing you have to do here. And this is just a standard report that we were able to use and manipulate to make it work for us. Another example was to take, again, this is the data normalized calc sheet, and on the previous page here in DN, you can see at the bottom is the data normalized sheet. And this one, we actually wanted to pull in some data and then send this file or send this data to an email address. And we were able to do that and export this file as either a CSV, a .dot file, or a PDF. And then once that data is entered or sent, then that person can double check, make sure everything is okay. And then that can be sent to the regulatory entity if they need to. And then we have park reports. In this case, we didn't actually do any park reports, but just wanted to mention that these are great because you can auto-generate them, or like I said earlier, connect them to alarms with the workflow. So if you do have something, you're able to go ahead and look at this report. And there's a lot of flexibility, especially if you are familiar with SQL. You're able to create these reports and get them set up. And then lastly, we were able to create an application to upload an XML file to a regulatory information submission system. So it had a review process, very similar to the sheet I showed earlier. And then it generated a file and uploaded it to the system so that there weren't as many steps for the user to do. So finally, if you're looking into creating your own energy and environmental management system, a few things to keep in mind. You want to know what data you currently have and what data you need. So how are you wanting to get that information consolidated? Is it going to be with MDEs? Could you use a SQL tag template? Is the data already somewhere else? And you like that system that you're using to enter the data, and maybe you just need a SQL tag template to get that data into Parkview or into wherever your data management is. And then it's important to know who needs to see the data and how. We're gonna probably give different information to different people. Operators and supervisors need data now, what is currently happening, whereas maybe upper management or the C-suite level is more going to want those monthly reports. So a graphic is going to work better for operations and daily usage, whereas maybe an Excel sheet or a park report is going to be better for those monthly summaries. And then I would say make sure you utilize limits before creating alarms. This saves time because you can create all of those alarms at once, And it's really nice to see the limit value on the trend. Again, if you just create that alarm at a max of 10, it will highlight red on the trend when it goes beyond the limit, but you won't actually know for sure what that value is because that line will not appear. And then lastly, try and keep or get all your data in a centralized location for monitoring. Really helps and makes things go a lot easier. So that's all we have for today. We'll go ahead and open up the floor for questions. Looks like we have a few questions. So I'll go ahead and ask them to Pekka. The first question we have is about PLS and PCA models, and if they are predictive or how you may use them in a process. So maybe you can explain those a little more.
Yes, excellent question. So predictive models, the concept of predictive models means that you are predicting a value based on other measurements. So basically you build a soft sensor. So that's a PLS modeling. You build soft sensor, you find the correlation from other measurements to produce the known result. For example, if you have a lab value, which is measured every now and then, and you know these lab results, then you create the PLS model, the predictive model, so that you find the correlation how other measurements are producing the same results. And these kind of PLS models are in DataPark very easy to create. So basically integration of trending. So you just pick up the tags, you run some analysis, you select the time period and you build the model, and then you have it right away available for any application. And it's also very useful when you talk about environmental data, like for example the BOD that was discussed already during the session. So you can build an estimator for BOD, so then you can identify already changes before, and as we discussed, the lab values are coming so late that you can then have a kind of early warning if something starts to happen in the process. That's just one example. And you mentioned also PCA modeling. So PCA modeling is a way to cluster the data, so you can define the let's say normal process situation, and then use that as a baseline. And then if the process starts to drift, you can, with PCA models, you can identify this drift. So this is also in the certain processes where the process values are very much operating point dependent. This can be extremely valuable, and when the processes are drifting slowly, can be extremely valuable as well to have the model that tells you that now my process is moving away from the normal conditions.
Great. And then another question we had is, if a site already has DataPark, are there any additional licenses that they would need in order to utilize these ESG or environmental applications that we showed?
Right, so that was also a good question. So in DataPark, in basic licenses, we have a lot of functionality available. And for ESG applications, you don't necessarily need any additional licenses. Only things that come to my mind is that if you don't have Park model license yet in your DataPark system and you want to build PLS models or PCA models, then you need Park model. And then maybe, you know, our licensing concept is very simple, so you get lots of functionalities with the tools license. So of course it might be that if you add a lot of new tags, that you have to check that you have enough tag count. But all in all, so there's no special license for environmental applications. You can basically, for what we discussed regarding typical environmental applications for gas emissions monitoring, energy management, or effluent water treatment, you can build these applications with basic standard DataPark licenses.
Okay, great. I'm not seeing any other questions come through, so thank you everyone for joining. And if you have further questions, you can definitely ask those on the community forum, or there should be a survey after this. So thank you all for joining and have a great rest of your day.